Hey guys, welcome back. We've been focusing on naming ionic compounds in class the past couple of days, and so we're going to go ahead and shift gears now and talk about the two places on your flowchart where the molecular compounds are found. And that's these guys right here. The binary compounds that don't contain metals, and the compounds that have multiple elements that have H's in front. Now we're going to start with these guys over here, those compounds that have H's in the front, because they are really, really special compounds. Anytime you see an H first, it's something called an acid. And we don't teach naming rules for these things. There's just 3 acids that we ask you to memorize by structure and name. So in your notes, make sure you write down these 3 compounds: HCl, H2SO4, and HNO3. These are the 3 acids you just have to memorize. That first guy's name is hydrochloric acid. H2SO4 is called sulfuric acid, and HNO3 is called nitric acid. So for your naming test, you simply have to know the compound and the name that goes with it. That's it. So now let's focus where there are rules, and that's the part of your flowchart where we have binary compounds that are only nonmetals. Those are going to be called our type 3 binary compounds, and they're very different from our ionic compounds because these guys contain only nonmetals. That's it. So these are going to contain elements that are found only on the right side of your periodic table. So if you see no metals present, you want to use this set of naming rules. Now the big thing about it, because it's not metals, is they are not ionic, and that's super, super important. They don't make positive and negative charge. What they do is they share their electrons. So they learned early on in kindergarten that sharing is caring. So because they share their electrons, they don't transfer them like ionic things. We have to have special naming rules for them. Now you'll notice that it still follows the first name, last name format. And it's pretty similar to what we've been doing before. If we're looking at the first name for your type 3 binary compound, what you're going to do is you're just going to copy the name from the periodic table. So that part hasn't changed. That's pretty consistent for all our naming rules. That first element just gets the name from the periodic table. The second element, you're going to change the name to an IDE ending. So just like we were doing with our ionic naming, if we had an oxygen second, it would become oxide. So these naming rules look really similar to our ionic, but where they start to change is in this purple step right here. What we do is we use prefixes to show how many elements are present. Because since they don't make positive and negative charges, there's no way for us to figure out based on math how many of each element should be present in the compound. So the name gives us the exact number. So all these prefixes indicate how many atoms are present. So if you see the prefix mono, that means you have 1 element. Di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, and deca means 10. So these prefixes are things that you're definitely going to want to make sure that you memorize for your naming test, because these tell us how many of our elements we have present. Now here is the tricky thing. This prefix mono is only used for the second element. It's never used for the first element. What do we mean by that? If I'm looking at the compound CO, made of carbon and oxygen, the name is not monocarbon monoxide. The name is carbon monoxide. So this mono prefix only gets used for the second elements. You would only use it for the second name. That's it. The first name would just only be the element name. All the other prefixes, di through deca, get used for both elements. So mono is only used for the second element. All the prefixes are used for all the elements, first and second. So let's go ahead and let's give 3 a try. So you'll see these 3 examples in your notes, so let's go ahead and use these with our new rules. Now, how do we know that they're molecular compounds? If you look at the formulas, you'll notice that there are no metals present. I, F, S, E, O, B, and O all come from the nonmetal side of the periodic table. So that's how you know they're molecular, because there are no metals present. So we use our naming rules to go ahead and give them their name. So the I is going to give us our first name, and that's going to be iodine. The F gives us our second name, and the 5 tells us how many we have. So we look at the chart, we find the number 5, and see that the prefix is penta. So we can go ahead and write that down. And the F is fluorine, but since it's our second element, we're going to change it to fluoride. So iodine pentafluoride is the name of our first example. This next guy here, we again have single elements present, so we never use mono for the first element. So Se, we just copied straight off the periodic table. So that would be selenium. The O is oxygen, and there's only one of them present, so we use the prefix mono, and the oxygen becomes oxide. Now, because we already have an O present, we don't have to do mono and then the word oxide. You can just call it monoxide. So selenium monoxide is the name of our second example. Our last example, we have we have subscripts for both elements, meaning we're going to need prefixes for both elements. So we look at the chart, and the 2 means di, and the B tells us the element's boron. So the first name is diboron, the last name, the 3 means tri, and the O again is oxide. So diboron trioxide would be the name of that last example. Now here's the mistake you're all going to make. Because we now have prefixes in play, you're going to look at every single compound we have and you're going to give everything prefixes. You cannot do that. The only compounds that get prefixes are when you have all nonmetals. So when you're looking at a group of examples, don't start naming things willy-nilly. Maybe go through and identify all the ones that contain all nonmetals. And those are the guys you can start with using your prefixes. The other guys are ionic, so they would have to use the naming rules we learned earlier in the week. Now, just like our ionic compounds, we not only have to be able to go from a compound to a name, we have to be able to go from a name to a compound. But this is so much easier than ionic because there's no math necessary. The name tells you everything you need to know. The word carbon with no prefix tells me I'm just a C. Dioxide, we know the di means 2, and the oxide means oxygen. So my second element is going to be O2. So I would be CO2, carbon dioxide. Carbon tetraiodide, again, no prefix, means C. Tetra, we know, means 4. Iodide means iodine, so I would be Ci4. My last example, phosphorus pentafluoride. The phosphorus means P. Pentafluoride, penta we know means 5. Fluoride means F. So I'd be PF5. So that's it. We've now completed our flowchart. So we've learned how to name our type 3 binary compounds and our acids. So what I would do right now, maybe on my notes, is I would maybe jot down a few notes about the rules for naming type 3 compounds. And I'd maybe jot down the 3 acids you need to know right here in the space on your notes. So that way when you're doing your practice, now you can go ahead and follow the flowchart step by step to get you to the right set of naming rules. On your Google form, I'd like you to go ahead and answer these 2 questions. I have 3 compounds that I'd like you to provide the name for on your Google form. And then you'll see a little question in the second box that's going to ask you how many of something is found in these names. Remember, if you've got questions, I'm here in the morning all the time, so feel free to swing by and ask. Have a great night, guys.